Okay guys, in this video we are going to do an exercise. Alright, let's do a bit of exercise for vector. So exercise 3.1. From example 3.8, find vector BC and vector AC. Let us revise a bit. How can I know that they are requesting for vector? Of course, because of the notation. And this notation gives us the direction. So the direction of the vector later should be from B to C. Right, and this one is from A to C. So let's look at example 3.8. Now they given A 163, B 427, and C 915. So based on the given information, we know that they are a three-dimensional graph. Alright, why? Because it has three components in each of these coordinate x, y, z, x, y, z, and x, y, z. And again, how can I know that this is a coordinate, not a vector? Because of the bracket. It is a round bracket indicating a Cartesian coordinate, right? So as you may know already, to find a vector B to C, for example here, we'll need to convert each of these coordinate into its position vector, or maybe just into its vector, right? So what will happen here is that we are going to first change each of these coordinate in a form in a form of vector. I mean the information here, we're going to change it in the form of vector. In other words, a position vector. So before we do that, let's try to graphically look at the information given here. So this is a 3D graph. Let's see where A, which is 163 is, and B 427, and C 915 is at. Okay, so based on this, you'll see that this is A. Okay, this is A, and then this is where B should be. Okay, and next we have C. Okay, which is here. So this is all the point that they want us to look at. Again, this is just a Cartesian coordinate, and the first they want us to look for vector BC. Okay, to look for vector BC, right, we'll need to subtract from C to B. Right, from C to B. Now notice on the bracket in the question here, C 915 and C 915, they have an equal number of x, y, and z, but different kind of bracket. Basically, this indicate a Cartesian coordinate, and this indicate a vector. So what's really the difference between these two? Let's look at it graphically. Right, this will later show you that this is not a coordinate. This is the difference of C from the origin. Okay, and this will be the difference of B from the origin. Okay, so now this is C 915. Now when you subtract C with the origin, which is 0, 0, 0, of course you are going to get the same thing, which is 915. So basically 915 in our vector calculation is not the coordinate, it is actually this. Right, we are actually showing this line here. This actually being represented by a pointy bracket 915. Okay, the value is the same because we just subtract it from 0. Okay, now The same goes for B. The pointy bracket here indicate that this 4, -2, 7 is a vector from, basically B here is being calculated by subtracting with the origins to get the difference. So because of the difference again is just subtract with 0, we are going to get, of course, an arrow from the origin to B. Right? So let me try to pull it out again. Where is it? Okay, there you have it. This is the vector of B. Now the question one is to look at the vector B to C, meaning we need to subtract C to B, right? Subtract C to B to get vector BC. So when you subtract C to B, okay, wait a minute, you should get this, okay, and this is in terms of graphic. Numerically, when you subtract between B to C, you should get 5, 3, -2. This value here indicate the difference from B to C. Right? So the question actually interested in finding this one, which is you don't really need to know this. Sorry, these two. So this is actually the answer graphically, and this is the answer numerically. Of course, you don't need to draw it down. I just want you to show you to have a sense, right? What does it mean by vector in terms of graphic? Now let's look for C minus A. So basically, C minus A, we should subtract A to C. So A is actually 1, 6, 3, right? Minus with C, which is 915. 915. Okay. So how do we subtract it, right? I simply subtract each component individually. 1 minus 9, -8. 6 minus 1, 5. 3 minus 5, -2. This is the answer of vector CA. And let's try to look at it graphically. Where is it actually? So CA. So vector CA should be at this point, right? It should pointing from C to A. Okay, this is how it's look like graphically, right? But again, you don't really need to draw it, right? What's important is this calculation, right? So let's look at another example on now magnitude. Okay, let's look at magnitude. What does it mean by magnitude? Really, length, right? Length. So they want us to find the magnitude. Now let's try to use our previous example to find its magnitude. We know that the let's look at CA here. We know that graphically this is how CA looks like. This is its length, right? C to A. But finding its magnitude is actually means finding its length. How long is this line? So to find it, as I said in our previous video, we are going to calculate it the same as what we did in chapter 1 when we calculating modulus. So in other words, to find the length, right? Let's say for CA. So this is how we should write it down. So CA, okay, and we want to find the modulus. So this should be the notation. Right? So equal to square root of negative 8 squared plus 5 squared plus negative 2 squared. Okay, let us calculate that. Okay, so the length is 93. Okay, so we can also, if you want to treat it as a final answer, we can also just set it and you'll get 9.64. Alright, so basically this is the length, 9.64. As for now, we don't know what is the scale yet because we don't really have an applied equation. So if let's say all of this value is in centimeter, then we know that 9.64 centimeter the length, right? So usually in engineering we are going to just leave it like this so that we can bring the whole thing, right, as I said before, right? If not, you need to put on a lot of decimals. Okay, so that is modulus on how to find it. Okay, you can try to do it by your own on other exercise here. Try to find the modulus, the magnitude. In this topic we call it a magnitude. Okay, so alright, in the next video we're going to talk about unit vector. Okay, thank you.